So starting today, this definition was given to us in chapter 11.2. It says a sinusoidal function with range min is less than y is less than max. The principal axes. The principal axes is actually what we've been calling the midline, which we didn't talk about yet. But that's the equation of the midline. So in your textbook this year, it's called the principal axes. In the textbook last year, it would have been called the midline. So just so we understand that's what that means, okay? It's the horizontal line located exactly in the middle of the range of the function, and the amplitude is the vertical distance above or below that middle line, okay? And the midline is always written as an equation. I want to remember that as well. We can always write it as d equals, or I would accept y equals, but I'd prefer d equals because d is the part of the equation that we're used to seeing. We'll take a look at that type of stuff today. So that's what the midline is. The amplitude is, we can say it one of two ways. We can say the distance to the max from the midline, or the distance to the min from the midline. All right. And then the final thing was the period of the function, which we talked about was, it's like basically the length of one cycle of the function. And it's found by doing 360 over whatever the b value is. And I guess important to write down, we'll write down what the equation looks like just so we know where the d equals is coming from. So parent function is going to be y equals a sine of bx plus d, y equals a cosine of bx plus d. Those are the two parent functions for sine and cosine respectively. So a is the amplitude. B is what we use for calculating the period. And then d, whatever's being added at the end, is where the equation of the midline comes from, which is why I said you should use d equals. Oops. And then this b value, b over x, that's where, or b times x, that's where that stuff comes in. All right, so those are the three important things we want to remember. What we're going to be looking at tomorrow specifically is, like, if I give you a data set, how do we find those three values and then write an equation from it? So writing these equations. But today, it was just more practice of, here's some information, how do we break it down? This is kind of what to expect on the IB exam for this type of problem. We just have to know how to interpret it. So whenever I see an equation like this one, it says the graph of a function y equals negative 20x, or cosine of 3x is shown on Clara's graphing calculator. Write down the amplitude of the function and justify your answer. So first thing you could do is actually graph it. So graph it yourself. And the amplitude is just going to be 20. It's got a negative 20 there, and negative does one thing and one thing only to a graph. Does anyone remember what a negative does to a graph?
It reverses the
Yeah, it's a reflection. It flips it.
All three of us like, what's that?
Yeah, all of us are like, it does something, right? Yeah. So amplitude is always an absolute value. So amplitude is always positive. And when it says write down the amplitude of the function and justify your answer, you would just say the maximum is 20 units above the midline or above the principal axis. That's what it means by justify your answer. And that's why I'm saying graph it so you can visually see it. And that's how you're justifying it. Okay? You don't want to just say, because it's the front number. No, that doesn't work. Okay? Write down the period of the function and justify your answer. So I would do 360 divided by 3, and I'm going to get 120. Again, my calculator needs to be in degree mode. If it's in radian mode, it's not going to work. But if I'm in degree mode, I should get 120. And then I should say, looking at the graph, peak to peak is 120 degrees. All right, that's what I would say basically for this problem. That's how you justify the answer. So understanding what each value means and how to use those values to help us solve. All right, that's it. That's the idea today. Can we break down these equations and identify what each part means? Okay, not too bad. Example 3, this is kind of what we're going to be doing tomorrow, is trying to break down. Tomorrow we're going to break down how to write an equation from a data set. And this one says specifically, hey, we've got this principal equation, a sine of x, or sine of bx plus d, where x is the number of hours after midnight. So midnight is essentially hour 0, 1 a.m. is hour 1, 2 a.m. is hour 2, etc., etc. So, for example, what that means is we could tell ourselves, oh, 3 a.m., that's hour 3. 9 a.m., that's hour 9. Okay, so I'm just going to make a quick note of that so I know what this is saying. And so what happens is Simon's laptop unfortunately crashes, but he found a piece of paper and he wrote some of his data down. And this is what he has. He says he found his maximum at hour 3, his minimum at hour 9, and he's got these coordinates here. So what we need to do is we need to find the A, B, and D values. All right, that's the first thing we're going to do. And then the second part, the more important part, is we need to interpret what those values mean in a real world context. Okay. For an IB test, we're going to be in degree mode all day, every day for these problems. Okay, degree mode for an IB exam. Okay. So first, how do I find the amplitude of this equation? Do I just do the max minus the min? 11.2 minus 5, and that's it?
Minus min divided by 2.
Yeah, max minus min divided by 2. 11.2 minus 5 divided by 2. Okay, that's how you find the amplitude. So that's going to be 6.2 divided by 2, 3.1. So my amplitude, my A value is 3.1. Sorry, I moved away from that. I'm going to zoom out a little bit. That's it. All right. The D value is the midline, All right, or the principal axes in this case. What we do to find the d value is we have to find what's exactly in the middle here. So halfway between 11.2 and 5. Okay, so what we do is we add them together. It's the opposite of what you do to find the amplitude. Add them together and divide by 2. Okay. So 11.2 plus 5 is 16.2. Divide by 2. And then you get 8.1. So your midline's at 8.1. Which makes sense because the amplitude is 3.1 and the minimum's a 5. So if I did 8.1 minus 3.1, I would get 5. All right. Once I have the amplitude, I could also just say, let's add 3.1 to the minimum value, and I'll find that midline as well. So there's a couple ways to do that. So D equals 8.1. The last one is to find the period of the function. I got to find the period of the function to find the B value. But do I have one full period on my graph here? If I'm going from a maximum to a minimum, how much of the period is being covered?
Half.
Exactly, half of the period. Good job, Chloe. So yeah, maximum to maximum would be the full period. Maximum to minimum is just half. So I'm going from 9 to 3. That distance is 6. So 6 is half of a period. So the full period is 12. Logically, we have to think about it that way. Full period is 12. Okay. Now, I would say the way to solve for period is 360 over B. So now I just have an algebraic expression to solve for it. Multiply both sides by B. 12b equals 360. Divide both sides by 12. B equals 30. Okay. So that's our B value. We got our A value is 3.1. And our D value is 8.1. Now I'm just going to go ahead and write the equation. Let's write it in green here. F of x equals 3.1 sine of 30x plus 8.1. All right, now is the important part. How do I interpret these values? So what was Simon looking at in the first place? What was he exploring? We go back to the very beginning of the problem. He's looking at tidal patterns by measuring the depth of water at the end of a pier. Okay. So he's walked out to the end of a pier, and we got the ocean. That's two. Ocean in blue. And then we've got our sandy beach over here. And then there's a pier. So he's down at the end of the pier here, whatever, staring into the water. And what we're going to see is the average depth here should be our midline, 8.1. So that's what the D value is. The average depth is 8.1, and we're going to see the tides going higher. So the water's getting deeper as the tides get higher, or the tides getting lower and the depth's going to get lower as well. That's what's happening. So the D value, 8.1, that represents like the average depth of water at the pier. Okay. Now I want you to think about the A value. The B value is a really hard one to think about, but the way I want you to think about the B value is don't think about the B value itself. Think about what the period of the function was telling you. What's the 12 telling you specifically? And think about it in context of tides. What does 12 have to do with tidal things, okay? With the changing of the tides, okay? So think about those two for a second.